Greetings, everyone. Thank you for joining us here today for another of our Lunch and Learn webinar series. My name is Mary Beth Iyer, and as your host today, I would like to thank you all for taking your time and joining us for this webinar. This webinar will be available for you on demand previews after the conclusion of this live segment. Just use the link you followed here today, and the recording will start. Additionally, you can visit our YouTube page and take a look at the playlist with all of our other webinars we have done in the past. They're all available for you there. Also, if there is any additional information or technical services that my company can provide relative to this or any other equipment we represent, please do not hesitate to get in touch with us after the broadcast. Our company specializes in representation of pharmaceutical production equipment, largely for parenteral applications. We are based in St. Louis, Missouri, with offices and project engineers additionally located in Illinois and Minnesota. From aseptic environments through container integrity testing, our company has been involved in over 5,000 equipment projects throughout the Midwest. Detailed information can be found on our website. Fedegari is a manufacturer we started representing a long time ago. They are a company that was founded in 1953 and is focused on production of equipment and technologies for pharmaceutical grade sterilization, washing, and decontamination systems. They have extensive international infrastructure, including 2 offices in the United States. Today we have Daniela Martigani and Maria Luisa Bernuzzi from Fedegari's research and development chapters, representing 5 case studies where they focused on multiple key factors specific to each scenario that they completed successfully. But first, let me just say a big thanks to Mr. Jim Agalloco for joining us here, and he will do a short intro into the challenges we need to account for when deciding on how that decision will be effective. As mentioned previously, Fedegari is a company with significant infrastructure in the United States to support its operations here. They have an installed equipment showroom, product development laboratory, and training and services center. Their infrastructure in the States and domestically is better than even our local manufacturers. If anybody needs additional information relative to the Fedegari product line, again, please don't hesitate to contact me or marketing@fedegari.com. Thank you very much.
Hello. First, I'd like to speak to you a little bit about cleaning validation in the very largest sense. So cleaning is a very complex subject. There are many, many aspects of it that vary across the industry. There is not one cleaning solution that we can identify for all types of systems, all types of products, equipment. Just if you look at what we call the cleaning continuum here, you'll see some of the variables that come into play in establishing a cleaning validation program. And everyone at every site is going to be someplace a little different from everyone else. And not only that, across an individual site, you'll find your individual cleaning procedures will vary, and they will fit into different places in this continuum. So it's extremely important to have a thorough understanding of your process and then establish it based upon the specific needs for that place that you have to deal with, that system you have to deal with. So we commonly look at things in cleaning as to what has to be removed. And the 2 things in black are the things which we are easily identified and everyone seems to be very concerned about from a safety standpoint. The active ingredient and the detergent or cleaning agent that you might be using. And in some cases, actually, the rinse fluid, you do sometimes have to have the equipment very, very dry. So even if you're only using water to clean or rinse, that water has to be gone at the end of the process so that the equipment can be used in a proper manner. So if we think about that and say, well, those are the only 2 things we need to worry about, we're actually missing quite a bit. First thing we're missing are microbial contamination and endotoxin. It's important in all products to control the population of microorganisms, and it's also important for injectable products to control the amount of endotoxin present. So we have to have processes that can both reliably reduce and control the amount of microbial contamination and endotoxin at the end. And this, again, ties back into the rinse fluid. leaving something wet allows microorganisms to proliferate potentially, allows endotoxin to remain. So these things are not disconnected. They are all interrelated. Now, lastly, you have a bunch of other items on this list, decomposition products, excipients, particulates. These also are cleaning concerns in the sense that think of a product that might have a deep color. You have to remove that color. Yeah, there may be no active ingredient present. There may be low population of microorganisms, but the presence of that red excipient as a remainder on the equipment would make it impossible to make a white product subsequently. So while you don't typically look for the excipients, they can create a problem for you. The other thing about the excipients to understand is they can be more difficult to remove than the active ingredients. So even though we're not formally analyzing for them, it's important to consider that all of these items on the page have to be satisfactorily removed. Cleaning is a very complex process, and it's highly recommended you develop an overall validation master plan specifically for the cleaning operations. And some of the things here are very simple, common types of things. Well, the facility description, the utilities you have available to clean, the flows and things like that. But there are some really important elements of this that need to be set up before you launch into a cleaning validation program. What are your acceptance criteria? What limits are you going to impose on the samples you take to accept this as being clean? And there are a number of things coming from, mostly from Europe, on the amount of residual you're allowed to have. There are a lot of criteria used to set limits. You have to put your rationale down, define your limits, and then adhere to them. Having the limits then takes you to the next stage of methods. You need methods that will work at those limits, and they need to be good, quantitative, robust methods that are reliable so that when you get a result, you can say, yes, I know exactly how clean my piece of equipment is. You need all of the typical things about calibration, procedures, automation, controls, all of this. You need to identify your sampling locations. There's just a host of things here on these 3 slides that need to be addressed, and putting a plan together is essential. And lastly, you need to control change around the process of cleaning. The cleaning procedure has to be fixed. The material controls have to be established so that the cleaning agents don't change. You have to deal with changes to your product. A formulation might not have an effect from a therapeutic standpoint, but it might have a very big effect from a cleaning standpoint. So you have to consider all the potential nuances of change in looking at your process, adapting to it, and keeping yourself in a state of control. Similarly, changes to the equipment, whether it's a material of construction or it could be just the shape of something, could make a difference in how effectively things are cleaned. So these are all considerations to deal with in the idea of how to manage a cleaning program. First, to consider your unique place in the continuum. Second, to consider what is it you're actually trying to remove, and it's that whole list, even though you can't formally assay all of them. And then to have a well-structured overall program for validating your cleaning. So with that as an introduction, I'd like to turn it over to the folks from Fedegari to take you into some of their experience and give you some ideas of things that they've done in that continuum for various clients. So Daniela, I think you're taking over next.
During this webinar, we will present you 4 different case studies. The first one, it will show you how a good engineering of the cleaning equipment is fundamental to assess the goal of a washing process. Case study number 2, it's about the removal of microbiological dirt, toxin. Case study number 3, it's an example of spray-covered test. Number 4 will explain you how it's important knowing the chemistry of the dirt in order to remove it. Let's start with the first case study, the removal of the soil from a dosing well, an example of engineering of the cleaning equipment. The picture here represents the dosing system on the wall. Next to the arrow, hidden by another metal part, the dosing well we both like clean. The customer wanted us to wash a powder dosing system, but he wanted us to disassemble the equipment in order to be sure about the dirt removal. The soil he had to remove at that time was carbapenem. For safety reasons, it was decided to use another soil with the same solubility as his drug. It was chosen mannitol. Here, there are some pictures of the dosing well we would like to wash. The dosing well was dirtied with mannitol, and it was located into our R&D washing machine. A stainless steel spider was inserted into the wheel in order to reach every inner surface of the wheel itself. And two spray bars with nozzles were located above and under the metal wheel in order to clean the external surface of the wheel. Here, the spider drawn by our engineering department and some sections with the spider into the dosing well. Here, the real one. Here, there are some pictures which represent the spiders with some holes. Through this hole, water is coming out during the washing phase, and compressed air is injected during the final drying phase. After the washing cycle, the stainless steel wheel was visually clean. Any analytical investigation was performed at our site, but the customer performed some swaps on the surface in order to collect residuals and to analyze them at their own laboratory.
The second case study was about endotoxin removal during a washing cycle. New cleaning equipment is becoming more and more widespread, removing a different soil which is not chemical but microbiological. Now, a very frequent requirement is removing bacterial endotoxin. Endotoxin log reduction, which is a standard requirement for the depurogenation process, might be the additional target of a washing procedure. The required reduction will not be achieved due to the high temperatures, but due to the mechanical removal effect dictated by the cleaning medium, such as water, steam, or aqueous solution with the addition of detergents. For this case study, we use coupon of different material used in the pharma industry. They were inoculated with a predefined quantity of endotoxin. Appropriate supports for the coupon were studied to ensure that the washing medium reached the inoculated coupon surface. In addition, an appropriate cleaning equipment composed of rotating arm with nozzle was designed and built. In this picture, the coupon inside the chamber of our R&D machine with a spray bar above and under them. The cycle was mainly composed by various washing phases with water recirculation and a washing phase with water disposal, injection, and simultaneous drain of water. At the end of the cycle, the result was 3 endotoxin log reduction. Everything was analyzed using chromogenetic kinetic method, as described by the pharmacopoeias. The third case study is about the spray coverage test. A customer of us wanted to wash aluminum seals and asked to prove the efficacy of the cleaning equipment for the specific load. So we perform a spray coverage test. A water solution containing a fluorescent component was sprayed onto the surface to be clean, the aluminum seals, including the trolley structure, the fixed spray nozzle, the rotating spray bar, and the chamber wall. A water solution composed by 0.4 gram of riboflavin, 1 gram of dextrose, and 1 liter of deionized water was composed. We added dextrose to make a thicker solution. It was a worst case. The surface of the aluminum seal were kept at rest until a complete dry of the solution. Appropriate supports were studied to ensure that the washing medium reached the aluminum seals. In addition, an appropriate cleaning equipment composed of rotating arm with nozzle was designed and built. In this picture, you can see the support for the aluminum seals, the spray bar above and under them. The washing step included simultaneous hot water injection at above 75 degrees Celsius, washing, rinsing, and drain. After the cleaning procedure, the surface of the aluminum seals was inspected by the UV lamp for riboflavin residues. Result of the washing treatment: no yellow spot has been detected after the cleaning treatment.
Study number 4, collagen removal from a metal bowl. This study number 4 will explain you how is important knowing the chemistry of the dirt in order to remove it. A customer asked us to wash a stainless steel bowl contaminated with collagen. Collagen was in fact located on the surface of the bowl, on the inner surface of the bowl. It was a sticky powder. We placed the bowl on a metal support inside our R&D wash machine, and we located a spray bowl in the middle of it. The washing steps we perform at the time were a steam injection at 85-90 degrees Celsius and a rinsing phase with hot water, 75-80 degrees Celsius, in order to use the mechanical action of water to remove every residual from the inner surfaces of the bowl. Collagen is a protein, and for a protein, the exposure to it has to be avoided in order not to fix it on the surface itself. Looking at literature, we read that collagen is usually degraded at 45 degrees Celsius. The degradation at the high temperatures of the steam injection converted, in fact, the sticky powder into a gelatin, easier to be removed by the mechanical action of water. This is an example of how degradation is useful to reach the final goal of our cycle, the cleanliness of our equipment. At the end of the cycle, the bowl, in fact, was visually clean. Another case study now, the gelatin removal from a dish. A known leading capsule manufacturer asked us to wash, dry, and cool a dish used to produce capsules. The dish was contaminated with a solution composed by a gelatin and a strong color pigment. Here, some pictures of the dish dirtied by a gelatin. The washing process was performed in the washer sterilizer FOWS. The treatment was developed with 2 bars with nozzles for the injection of the ionized water, steam, and compressed air. The 2 bars were fixed on the bottom of the chamber. The dish was fixed upside down inside the chamber in correspondence to the spray bars. The washing steps we performed included the dish immersion with steam injection at about 100 degrees Celsius, a mechanical action, a bubbling phase with simultaneous compressed air and steam injection through the bars was in fact performed. At the end, a simultaneous hot water injection, washing, rinsing, and drain. The result of the washing cycle at a visual inspection was again clean. Some final considerations. The studies conducted demonstrated that each load needs an accurate evaluation before defining a cleaning strategy. A customized solution might be preferred compared to standard practices in order to achieve highest process performances. The equipment chosen to perform the cleaning strategy, combined with the suitable treatment and accessories, are crucial to obtain a higher level of cleanliness, even with the most critical parts.
If that is all, then I guess we can go ahead and move on and just say thanks to you guys for having this presentation with us, and thank everyone who attended, and encourage you guys all on-demand viewers to register for upcoming live streams and send their comments or questions to us. Once again, I'd like to remind you that you can check out the playlist with all of our past webinars, including this one from the Lunch and Learn series on our YouTube channel, and you can set a reminder for upcoming broadcasts. And my thanks to all attendees, to our guest presenter, and extending their knowledge on the subject. So we can, we'll get a hold of you guys if there's any other questions. If anyone, after watching the webinar, even not the live version, if you have any questions, just contact us and we'll set up an appointment so we can pursue your project further. Thank you guys.
Thank you very much.